Let me ask you something. What if there were a door in the universe? A door that could take you across galaxies in an instant, faster than light itself. A door that might not just bend space, but bend time. Would you step through it? Close your eyes. Picture the stars around you folding, like fabric being pinched together. Suddenly, 2 points that were once light years apart are touching. In 1935, Albert Einstein and his young colleague Nathan Rosen discovered something strange in the equations of general relativity. The math hinted at tunnels, bridges hidden in the fabric of space-time itself. Imagine, in one corner of the universe, a black hole. In another, a second black hole. And between them, a secret passage. They called it a bridge. We call it the wormhole. For decades, wormholes were nothing but math and imagination, until 1988. Physicist Kip Thorne asked, what if a wormhole could actually be traversable? But there was a problem. A wormhole is like a tunnel in a collapsing cave. The moment it opens, gravity forces it to slam shut. To hold it open, you'd need scaffolding built from something stranger than anything we know. Negative energy. Now, negative energy sounds like science fiction. But in quantum physics, the Casimir effect hinted it might exist. Tiny, ghost-like forces appearing between plates of metal. But here's the catch. We've only measured it in amounts smaller than a single atom's weight. To keep a wormhole open, you'd need trillions of times more. Still, if wormholes are possible, they wouldn't just be shortcuts through space. They might also be shortcuts through time. Here's how. If one end of a wormhole moved close to the speed of light, while the other stayed still, time would pass differently at each end. One mouth would age slowly, the other quickly. Step through. And you don't just travel to another place. You leap into the past, or the future. And that's where paradoxes begin. The most famous, the grandfather paradox. If you went back and prevented your own birth, how could you exist to go back at all? Physicists offer two answers. First, the self-consistency principle. The past can't be changed. No matter what you do, events twist themselves to preserve the timeline. Second, the multiverse solution. Changing the past doesn't erase your own future. It simply creates another one. Think of a river. Toss in a rock, and the water bends around it, but still flows to the ocean. That's the consistent timeline. But if the water carves a brand new channel, flowing to another sea altogether, that's the multiverse. So, do wormholes actually exist? So far, no telescope has spotted one. But scientists are looking. Some hunt for tiny echoes in gravitational waves, ripples in space-time itself, that shouldn't be there. In the 2000s and 20s, a few studies hinted these anomalies might even be wormhole-like structures. Skepticism runs high. Most anomalies turn out to be noise in the data. And yet, what if the universe is whispering its secrets to us in ripples we've barely learned to hear? Now imagine this. Humanity builds the first artificial wormhole, and you're the one chosen to step through. You take a breath. Gravity vanishes. Light folds like rivers of fire around you. Time itself slips from your grasp. Your heartbeat echoes, faster, slower, irregular, as though rhythm itself is breaking. At the tunnel's end, only two possibilities await. One, you emerge light years away, in another corner of our universe. Two, you step into a completely different reality, beneath a sky no human eyes have ever seen. Maybe wormholes aren't just out there in space. Maybe they exist within us, bridges between our memories, our dreams, our choices. Scientists, dreamers, explorers, they'll keep searching for this cosmic door. And one day, someone will step through. So let me ask you again, if such a door opened before you, would you step inside?